So hi everybody, in this section we're going to be finding angle measures of polygons. Now remember, if you're a little bit rusty on what polygons are simply shapes built with straight lines. So for example, a triangle. So with a triangle, remember we have three angles, and all three angles we know that they always have to add up to 180 degrees. No problem. Okay, now check this out. What if I draw another triangle here? So then this angle and this angle and this angle would give me another 180 degrees. So what I'm just saying is that if I have a quadrilateral, that means a figure, a polygon with four sides, the sum of these four angles is going to be 360, because it's basically two triangles put together. Now it could be a square, a rectangle, or not. It could be something like this, which we call a parallelogram. So this angle, this angle, this angle, and this angle, 360 degrees. Now what about something with 5 sides or 6 sides? So it's going to change every time, okay? But let me show you this really cool formula that no matter how many sides this polygon has, all we need to do is plug it into this formula and it'll spit out the number of degrees of the whole polygon. I should introduce a few terms. The first one is interior angles, and that's what we're talking about, these angles on the inside. Okay, so all these are interior angles. Exterior angles would be something like out here. Okay, but we'll be focusing on interior angles. Okay, so let's say we look at this pentagon here. So pent because it has 5 sides. Notice it's not a regular pentagon. Regular means that all the sides would be congruent. Okay, but definitely not the case here. So how many interior angles do we have? 5. 1, 2, 3, 4, 5. Next thing I want to remind you is that this is called a vertex, and when we have more than one, they're called vertices. Okay, so in this case we have 5 angles, we also have 5 vertices. The next thing is what we call consecutive vertices. So consecutive vertices, consecutive means just one right after the other. So these two right here would be consecutive vertices because they're right next to each other. So with these two right here, this one and this one, right next to each other. Now, this one and this one would not be consecutive vertices. Okay, so when we do not have consecutive vertices, we can draw diagonals across them. Okay, now notice if we have 2 consecutive vertices, we can't really do that, because if you draw a diagonal or tribe, you don't get anything, you just get the same side. So you can only draw diagonals across non-consecutive vertices. Okay, so now we've got that new terminology out of the way. Now let me just give you that formula that I promised you. This formula is going to give us the measure of the sum of all the interior angles given the number of sides that the polygon has. So here it is. Dun, 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 there it is. So the sum of the interior angles of any polygon, as long as it's convex, is going to be n minus 2 times 180. So let's look at an example. Well, let's try it out for a triangle because we already know the answer, right? So let's see how the formula works. The sum of the interior angles, so we can use the acronym SOIA. All right, so our SOIA is going to be, well, let's see, a triangle has 3 sides, so n is going to be 3. So 3 minus 2 times the 180. So then this is equal to 3 minus 2 is 1. 1 times 180 is 180. And bingo, it worked. Now we also have a formula for the sum of the exterior angles of a polygon. Now we need to be careful here. Let's first figure out what an exterior angle is. They're a little bit tougher to see than the interior angles. Definition of exterior angles. Okay, very simply, if you have an interior angle, and those are pretty easy to see. So like here, 30 degrees, okay, this one right here. All you need to do is extend one of the sides, so in this case this one right here, and then the angle made between the extended side and the other side of the angle, which is this one right here, is what we call the exterior angle. And here's a formal definition. It says, the exterior angle is the angle between the side of a shape, alright, so like this side, right here, and a line extended from the next side. So this is the next side, so if we extend it, boom, here it is. So in this case, this one would be 150. And always, 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 the interior angle, let me write this down. they're going to add up to 180 degrees. In other words, the exterior and the interior angles are supplementary. Is everybody okay with it? Alright, so let's move on then. So the sum of the exterior angles of any polygon is always going to be 360, regardless of the sides. Okay, so like remember the last one, some of the interior angles depend on the number of sides of the polygon. But for the exterior, no, it's always going to be 360. The only thing is you have to be careful. You only use one exterior angle per vertex. So like here on this figure, so you notice we have one exterior angle, 2, 3, 4, 5, whatever they measure. All 5 of them have to add up to 360. Alright, so here we go. So first thing I'm going to do is just add up these three. So this is 334. So between P, Q, and R, they add up to 334 degrees. Now I have no idea what the measure of angle T or S is, but I know that they're both the same. This right here and this right here, this notation means that they're congruent. Okay, so I don't know what it is, so I'm just going to call it X. So an X here and another X here. So I know that 334 plus 2x's has to be equal to, well, let me see, we have a pentagon. For a pentagon, the formula for the sum of the interior angles is what? 5 minus 2, which is 3, times the 180. Is everybody kind of with me? So we know that we have to be able to add all these guys up, and they're going to give us 540. Now we'll leave off the degrees and we'll just crunch those out at the end. Okay, so it's just a simple equation. We're going to crunch it out. So 2x is equal to 540 minus the 334. And then we're going to divide both sides by 2, and we're done. So x is equal to this right here. So the numerator, that's 206 divided by 2, and then half of 200 is 100, and half of 6 is 3, so 103. So the measure of angle T is equal to 103, and the measure of angle S is also equal to 103 degrees. And we're done. More. Okay, let's do some more. Let's see if I can find some more challenging problems for you guys.